So, on to Chapter 6, Chemical Composition. You probably know that the amount of sodium you get in your diet can be of some concern. If you or someone you know has high, well, probably most of you don't have high blood pressure, but if someone has high blood pressure, eating too much sodium can cause a problem and cause their blood pressure to go even higher. And yet sodium is an important component of our diets, and if you don't intake any sodium, then you're also going to have a problem. So it's something that we need, but we don't need too much of. And that's actually true for most things. I mean, I'm just going to go off on a tangent here. We tend to think of things as safe or not safe, right? But really anything is toxic if you take too much of it. You've probably heard stories of people who have died from drinking too much water. Drink too much water in too short a period of time, your body shuts down and you die. Does that mean water is dangerous and that we should never drink water? No, because if we don't drink any water, we're going to die as well. Same is true for oxygen. Necessary for life, but too much oxygen will kill you also. So most things are beneficial in the correct amount. And sodium chloride is the same thing. So sodium is very important. It helps to regulate your body fluids, but too much of it can cause high blood pressure. So the Food and Drug Administration recommends that you consume less than 2.4 grams of sodium per day. Well, do they mean we should be eating this highly reactive metal? No, they mean sodium in any form. So usually we eat it in the form of sodium chloride. Well, does that mean you eat 2.4 grams of sodium chloride? Or what? How much sodium is in sodium chloride? How much sodium chloride would contain 2.4 grams of sodium? And so this is a question that we can answer by looking at the formula and the formula mass of sodium chloride. So we know that the chemical composition of sodium chloride is NaCl. And we've learned how to write formulas now. The name is sodium chloride. We recognize that as an ionic compound because it contains a metal. And so then if we were to look at the periodic table and find the charges of those ions, we see that sodium is in group 1A, so it has a +1 charge. Chloride is in group 7A. It's 1 over from the noble gases. It has a charge of -1. So the formula is NaCl. So there's one sodium ion for every chloride ion. But the masses of sodium and chloride ions are not exactly the same. They're a little bit different. So we can't get information directly from the formula. We can't get information about the masses directly from the formula. So we need to calculate the amount of this element that we're interested in, the sodium. So we can calculate this using the chemical formula and looking at the formula mass. So questions that we can answer in this way would be how much iron is in a given amount of iron ore? Okay, so here's a picture of a mine, and they're scraping up dirt and rocks, and it has iron ore in it. It has iron in a compound. And the question is, well, if we need 5 tons of iron, how much ore do we need to scrape up before we get this amount of iron that we need? If we look at chlorofluorocarbons, these are implicated in the destruction of the ozone layer. And so it's the chlorine in them that causes the problems. There's different types of chlorofluorocarbons. How much chlorine is in a particular amount of these chlorofluorocarbons? These are the sorts of questions that we can answer.